Hi, I'm John Armstrong, VP of R&D here at Jumpcode Genomics, and today I'm going to talk to you about a universal infectious disease assay facilitated by CRISPR-mediated depletion. In the study I'll be presenting today, we used 8 COVID-positive samples and 1 COVID-negative sample ranging in CT values from 20.95 to 27.79. RNA was extracted from the samples and split into 3 aliquots. 2 of the aliquots were treated with Jumpcode's CRISPR Clean Plus total stranded RNA prep with ribosomal RNA removal, and 1 aliquot was treated as a control with no ribosomal depletion. The resulting libraries were run on the Element Biosciences sequencing platform, and the resulting data was analyzed through the 4 pipelines shown below, and these outputs were compared to those seen with the Illumina platform. I'll be showing those comparisons today. But first, let's take a look at some of the sequencing metrics that we see on each platform. Here in the table, we're showing sequencing metrics from total reads and mean sequence quality all the way down to % duplication rate. We can see here between the Illumina and Element platform that when considering % unique alignment to HG38, there's an average increase in an alignment on the Element platform of 2.4% and an average decrease in duplication rate of 6.47%. First, the data from the Element platform was aligned to the COVID genome reference using STAR, and the coverage topology, depth, and breadth were determined and compared to the Illumina platform. So here you can see when looking at the COVID genome coverage topology for 4 representative samples, as I mentioned ranging in CT values from 20.95 to 27.79, we see a nearly identical coverage topology, independent of CT value. You can see here that the Illumina coverages are in blue and the Element coverages are in purple, with a slight increase in coverage resulting from the Element platform. As CT values increase or viral titer decreases, of course, average coverage will decrease as well. When we look at the COVID depth of coverage comparison between Illumina and Element, you can see here that the depth of coverage is concordant between Illumina and Element with an R² of 0.99. And in the table on the right, you can see the coverages or depth of coverages for the Illumina and Element Bio platform for each of the replicates in the study. And when we compare the COVID genome breadth of coverages between the Illumina and Element platform, you can see the same here, that the breadth of coverage is concordant between Illumina and Element with an R² of 0.99 as well. And in the table on the right, again, the Illumina and Element breadth of coverage for the COVID genome is shown for each of the replicates for the COVID positive and negative samples. Next, we can look at gene counts resulting from STAR alignment to the human reference in comparison to the metrics from the Illumina platform. Here we show the comparison of gene counts for 4 representative samples ranging in CT values from 20.95 to 27.79. Illumina counts are on the x-axis and Element on the y-axis. The XY plots show that human gene counts are highly correlated between the Element and Illumina platforms with R² values of 0.97 or greater. The blue column in the table on the left shows the R² values for all sample comparisons. Next, moving through the analysis, we can look at data that's generated from Kraken-2, which is a Kamer-based composition pipeline. It allows us to understand what bacterial composition is in the sample, and then we can compare that as well to the Illumina data previously generated. And when we look at the concordant overlap of the top 30 organisms identified in Illumina and Element sequencing data, you can see of the 18 samples that were sequenced, 16 of the samples are 100% concordant between platforms, and 2 of the samples are 97% concordant, sharing 29 of the top 30 organisms. Next, when we increase that top composition to 49 identified organisms, you can see here that we still see a very high concordance, where out of 49 organisms, from 3 of the samples, we see that we have a concordance of 92%, 86%, and 86%. We took the data from the Element platform put that into IDSeq, now CZID, and then the output of CZID into Nextclade to identify the COVID strain from that sample. We can then compare the strain call to that we saw from the Illumina data. Here we show the strain calls for each of the samples and replicates for the Element and Illumina platforms. As you can see, all strain calls for samples and replicates were correlated except for sample R08, where there just wasn't enough coverage over SNPs in the COVID genome for Nextclade to make a confident strain call. So in summary, we're not seeing any bias from the Element platform. The data is effectively equal to that produced on the Illumina platform. The coverage topology of the COVID genome is highly correlated. The human gene counts are highly correlated. There's a high degree of metagenomic compositional overlap, and COVID strain calls are highly concordant. So thank you for joining me today, and come see us at jumpcodegenomics.com.